In this video I'm going to have a closer look at the equation of some straight lines, and in particular I'm going to take 5 straight lines, 1, 2, 3, 4, 5 straight lines, and I'm going to plot them all on the same set of axes. What I'm actually doing here is what we call a control experiment, because if you look at the names or the equations of the 5 lines that I'm going to be dealing with, something about them is identical every time, and one thing I am changing each time. So here you can see there's a plus 2 on the end, so it's y equals 1x plus 2. This time it's y equals 2x plus 2, 3x plus 2. This is minus 1x plus 2, minus 2x plus 2. So every single time the name or the equation obviously begins with y equals, that's consistent, but it's also ending in plus 2 every single time. The thing that's changing, which I want to emphasize, is simply the number of x's that we have every single time. And if you want to, where you see x, you could actually just write a 1x instead of it. And where you see minus x, if you want to, you could put minus 1x. So what I'm going to do is get a series of 5 pictures of straight lines, 5 straight line graphs, and I'm going to draw them all on the same axes, and we're going to see what the effect of changing this number of x's is going to have upon the picture. And we're also going to see that the plus 2, plus 2, plus 2, which is constant throughout this set of 5 equations, that means when we look at the 5 pictures there's going to be something which is the same 5 times. And so we'll be able to deduce something about the meaning of changing these values for the equation upon what happens to the picture. So we're going to do this very quickly now. We need 5 tables of values to draw these 5 graphs. Let's do it very quickly. So the first table of values, x and y, I'm just going to work out 3 points, 0, 1 and 2, and it's going to be the same 3 x values, 0, 1 and 2. I'm going to work out every single time, x value and y value, 0, 1 and 2, x value, y value, 0, 1 and 2, and finally x and y value, 0, 1 and 2. So very quickly, a very quick calculation, here we go. If x is 0, y will be 1 times nothing is nothing, add 2, that is just 2. If x is 1, 1 times x, 1 times 1 is 1, add 2, that is 3. If x is 2, you're going to get 2 plus 2, you're going to get 4. Okay, second one, 2x's plus 2 now is the equation of the line. So 2x's, 2 noughts are 0, add 2 is 2. If x is 1, 2 1s are 2, plus 2 is 4. And finally, if x is 2, 2 2s are 4, plus 2 is 6. Next one, 3x's plus 2. So x is 0, 3 noughts are 0, plus 2 is 2. If x is 1, 3 1s are 3, plus 2, that's 5. And finally, 3 2s are 6, plus 2, we get 8. Next one, we got minus 1x plus 2. Be careful, if x is 0, minus 1 times 0 is 0, plus 2, you get 2. If x is 1, minus 1 times 1 is minus 1. Minus 1 plus 2, that is plus 1. And then finally, if x is 2, minus 1 times 2, that's minus 2. And then you add 2, you get nothing. Okay, notice by the way, we do have 0, 1, 2. We always have patterns taking place in these tables, as you can see. But the relevance of that I will not make any comments about in this video. We'll talk about that in a different video. Last one, if x is 0, minus 2 times 0, plus 2 is 2. If x is 1, minus 2 times 1 is minus 2. Add 2, we get 0. And if x is 2, minus 2 times 2 is minus 4. Add 2, you get minus 2. So we get that table. What I'm going to do now is take a simple setup of axes and plot all these values on the same set of axes and get 5 straight lines. So here we go. I only need positive x numbers and I only need positive y's apart from that minus 2. So I'm going to set up something of this sort of nature to be able to plot this basic set of straight lines. So here we go. First one, y equals 1x plus 2. 0, 2, I need to plot 1, 3 and 2, 4. So on my x numbers I need to go 0, I'm going to go 1, 2 and 3 to be able to plot the x values. Now the biggest y value I need is the 8, and it needs to go down to minus 2 to get them all on the same picture. So I'm going to go up in 2s, 2, 4, 6 and 8 and down to minus 2. Okay, let's plot the first straight line. 0, 2, 0 across, 2 up is there. 1, 3, 1 across, 3 up, it's there. 2, 4, 2 across, 4 up is about there. Should use a ruler, but I'm just very quickly going to draw this freehand to give you the idea. Label it with its equation or name before we go any further. This is y equals, I'll write 1x plus 2. Normally we'd drop the 1 and just call it x plus 2, but I want to emphasise the 1 for the moment. So y equals 1x plus 2. Next one, 0, 2, same place. 1, 4, 1 across, 4 up. 2, 6, 2 across, 6 up. Join up with a ruler. I'm just doing it freehand to demonstrate. It's a bit wobbly, but never mind, you get the idea. And that is y equals 2x plus 2. Okay, next one. 0, 2. 0 across, 2 up, same place. 1, 5. 1 across, 5 up. And then 2, 8. 2 across, 8 up. And if you get yourself a straight edge and join up, you're going to get a straight line looking something like that. That's y equals 3x plus 2. Okay, let's go on to the fourth one. Y equals minus 1x plus 2. 0, 2, same place. 1, 1 this time. So 1, 1 is there. And 2, 0 is 2 across, 0 up, it's there. So for this one, this looks something like this. Let's label it. Y equals minus 1x plus 2. And then finally, minus 2x plus 2. 0, 2, that's that point again. 1, 0. 1, 0 is on the x-axis there. 2 minus 2 is 2 across and down to minus 2. So you'll end up with a straight line with a ruler that looks something like that. And that's y equals minus 2x plus 2. Well, I hope you can quite clearly see some sort of connection now between what the number of x is and what the picture is that you get. When we had y equals 1x plus 2, okay, it was sloping like that. 2x plus 2 is a bit steeper. Y equals 3x plus 2 is even steeper. So the number in front of the x is going to control how steep the straight line is. So slope, we call the slope number 3, or the gradient value 3. Gradient of 3, gradient of 2, gradient of 1. Now if I was to do y equals 0x plus 2, I haven't done it, but if I was, I'll just write it here, y equals 0x plus 2. That means we have got a line which does not have a slope at all. It has a 0 gradient or 0 slope. From common sense, a 0 slope is a horizontal line. And that is exactly what you would get if you did y equals 0x plus 2. So the equation of that red dotted line I've put in would actually have y equals 0x plus 2, horizontal line. It then goes on to y equals minus 1x plus 2, and you can see that the line tilts the other way into the negatives. Minus 2x plus 2, even steeper, negative. So it's a very simple idea. Slope 3, slope 2, slope 1, slope 0, then it flips the other way, slope minus 1, slope minus 2, and so on. So the slope value, the steepness, is basically the number in front of the x. And the bigger that number is, the steeper it is, the shallower will be the smaller number. Remember, if it flips to a negative, then the slope goes the other way. And the bigger the number, the steeper the other way it would be. So for example, if I wanted to put y equals 4x plus 2, it would look, without even doing a table of values, something like that. If I wanted to do y equals minus 3x plus 2, it would look something like that. Okay, that is basically the control experiment showing you what the effect of changing the x is. It controls the slope. The other thing that we talked about was the fact that the +2 on the end remains constant, and surprise, surprise, that is the thing that is constant. That is where it crosses the y-axis. The +2 on the end controls the y-axis intersection point, and that has remained constant each time. So that is the end of this little control experiment. Remember, the number in front of the x controls the gradient of the line. That is the end of this video.